Okay, as we start the second part of this, I noticed that I should have taken out an x squared. I thought I did, but then looking at the tape and checking it out, I realized I didn't put x squared that we're taking out of each term here. So rather than try to correct that, I'll let you note that I can make a little error and you have to be careful. Okay, let's go on now to part 2. We're asked to factor this. Now, this one's sort of tricky because as we look at it, there are no common factors. So this is going to be guess and check. Now, since my middle term is 34 and this last term is 9, I'm going to need to play around with this. So rather than do it live, I will do it on paper and then get back to you folks. Okay, I didn't spend too much time, but this is going to be a 4y and a 2y. Now, when I looked at the 9, I saw I had a 34 here, so I needed a 9. 9 times 4 is 36. And this is a 1. So my 34 needs to be negative, so this is going to be negative, and this will be positive. And if I FOIL that, notice this is going to check out. Now, this one is an equation, this one is just factoring, but if this were equal to 0, by the way, what would the factors, or what would the solutions be? Well, we would equal each of these factors to 0. So here this one would be y equals, transpose that, negative 1 over 4. And this one, transpose the 9, that gives you a positive 9 over 2. So again, this isn't set up that way, but if it were, we would factor it, equal each of the factors to 0, and then solve these mini equations. All right, in number 22 now, we have 49 x squared. I'm going to transpose that 25, equal it to 0, because this is an equation. Now, this is the difference of perfect squares, so it's going to factor into its conjugates. And this is 7x, 5, plus minus. So when I equal each of these factors to 0, this is x equals a negative 5/7. And this is x equals, transpose that, a positive 5/7. All right, evaluate the radical expression. Express your answers as an integer, simplified fractions. And we know this is not a real number because we can't have, under the radical sign, a negative value for squares, or to the 4th, or to the 6th, even powers. If this were a 3, that would be okay, if the index number was a 3. Okay, number 24. Simplify this expression. Okay, so let's put it up here. I'll pause it to save a little time. Now, again, the strategy is to put two sets of radical signs. Under one, we're going to put the greatest perfect factor of a cube here. And as I look at 81, that is 3 to the 4th. So 3 to the 3rd is 27 out of there, and I'm left with a 3, and then there's a 5. Strange how they put this. The x is not. Now, the perfect cube factor of y to the 5th is y to the 3rd, and I'm left with y to the 2nd over there. So now I have perfect cubes under the first radical sign and what's ever left over. So the cube root of 27 is 3. Cube root of y to the third is y. And then the third root, 3 times 5 is 15, xy squared. Okay, again, we're not trying to teach you to do this, just reviewing the strategy here. Hopefully you know how to do this already. All right, then we want to simplify this expression here. This is 27 over 64 to the 2/3 power. And to convert a fractional exponent into its radical form, we take our denominator 3, that becomes our index number. And then we want to square that. So this is going to be 3 to the 27th. And then we're going to square that. And that's going to be over 3 to the 64th. And we need to square that. All right. So setting it up this way makes it a little easier, where converting a fractional exponent to its radical form, the denominator of our fraction becomes the index number. These are the radicants, and then we're raising it to the second power. So 3 to the 27th, the third root of that is 3. 3 squared is 9. And the third root of 64 is 4. 4 squared is 16. So there is our answer. All right, so we're going to do number 26 here. And I thought we weren't doing those, but let me just set it up here. All right, so what I've done is I've isolated the radical by transposing the positive 5 to the other side, where it becomes a negative 5, so that's 0. And to get rid of the radical sign, we're just going to square both sides. So squaring or raising to a power, remember the 2's not written, but if we raise a power to that index number, it just becomes the radicand. And then transposing that, it's 5t equals 5. So t is going to equal 1. So if we put a 1 there, we get the square root of 0 plus 5 equals 5, and that checks out. So in this case, t is 1. Now for 27, they're giving us this function. Your answer should be simplified and written in radical form. So we're going to put, under the radical sign here, 5 times 9 plus 2. So where the x is, we're going to put the 9. So that's 45 plus 2, square root of 47. And since that's not a perfect square, that's an irrational number, that is the answer for that first part. And for the next part, we're going to have 5 times, again, our function here is a minus 2 plus 2. So this becomes 5a minus 10 plus 2. So the final answer is 5a minus 8 under the radical sign. Now consider the following functions. This is our f function. This is our g function. and we're asked to find G minus F. Express your answer in interval notation. Now, when we get our original answer, remember we need to find its domain. And our domain here, let's do that part first, is going to be 6 minus x. Will indicate what our domain is going to be limited to, because we can't have any value of x that would make this radicand less than 0, that is, a negative value. So we solve that by saying, take our radicand, 6 minus x equals 0, transpose that, and it would be greater than or equal to 0. So we take our negative x, bring it over, and that becomes a positive x. So x, if we write it the usual way here, with the x on the left, is less than or equal to 6. So in interval notation, it's going to come from negative infinity up to 6, and that has a bracket because 6 is included in the set. So we've done our domain, we just have to figure out what that other value would be. So let's clear this up and do that work here. Now, this is a little tricky because we're doing G minus F. So if we just set it up, what is G? Well, G is 9 minus X. This is our G. This is what we have here. Now we put a minus, and then we have to put in this part here, which is what F is, a negative square root of 6 minus x. So here's the tricky part. You have the opposite of a negative makes this a positive. So what's your final answer for this part is going to be 9 minus x plus the square root of 6 minus x, where we said the domain, after we figured it out earlier, was going to be that an interval notation was from negative infinity up to a positive 6 with a bracket. Okay, let's do statistics here. Show that the fractional part of a battery, B, that is still good after T hours is given by this right here. What fractional part of the battery is still operating after 100 hours? So we're going to put for T 100. So this will be 6 caret. And then notice it's a negative. Multiplying this by 100. Move that decimal place over, it becomes a 1, or just a to the negative 1 power. And 6 to the negative 1 is equal to 1/6. Just move that down to the denominator, and this becomes a positive exponent that we don't write. Okay, let's go on to some logs now. Let's raise it up a little. Now, remembering how much you can about converting from logarithmic form to exponential form. So our base here is 16. Our answer is, our exponent is a negative 1/4. And our answer is x. So a negative 1/4, this one's a little tricky, but not too bad. So what I would have done is take this 1 over, bring this down to 16 to the 1/4 equals x. And this is 1 over the 4th root of 16. And the 4th root of 16 is 2. So here x equals 1/2. So with the negative exponent, that was a little tricky here. Fractional. But remember, bringing it across the division bar down to the denominator makes that a positive. And then converting that radical, well, fractional exponents to its radical form makes it a little bit easier. All right, let's go on here. Where are we now? All right, use the property of logarithms to write the following expression as a single logarithm. Okay. So this will be log base 5. Now, since we're adding, this indicates multiplication. And then we can just join that together here. And I don't think they want it in this form. They want you to expand that, so it's log base 5 of x squared plus 8x plus 15. That's what I think the answer is. Again, I don't have the answer sheet, but that seems reasonable to me. All right, express the following equation in its exponential form. Okay. Now, our base here is, if you remember, is the letter E. So it's natural log of E of this answer equals K. So our exponent is K. This is natural log of E. So our base is E. Our exponent is K. And our answer is 53.3. All right, for number 33, solve this equation. Now, the rule here, let me write it up big here for you. 4, 3x minus 2 equals 2, 2x plus 2. If we can get this 4 to have a base of 2 instead of 4, well, I can do that by saying this is 2 to the second. So this was originally 4. I made it 2 to the second. So now my exponents equal each other. So this is 6x minus 4 equals 2x plus 2. Transpose, and this is 4x. Transpose, and this is 6. And then I get x equals divide by 4 and simplify 3/2. So the key here is to get our bases so they are the same. And then just once the bases are the same, we equate the exponents to each other. Okay, solve the following quadratic equation by using the definition of the square root. And simplify. Okay. So let's write this big too. 9y minus 27 squared equals 27. Now, the square root principle is we take the square root of this side and then plus or minus the square root of that side. So when we take the square root of something, it just becomes a radicand. 9y minus 27 equals, now the square root of 27 is the square root of 9 times the square root of 3. So this is going to be plus or minus 3, the square root of 3. As I simplify that, then I'm going to move that 27 over. To this side, it becomes a positive 27. Let me just erase this a little bit here. So this 27 on this side becomes a positive 27. Now I can erase it on the other side there. And now we're going to divide each by 9, so we can simplify a little bit. 9 and 9 and 9. So this cancels out, and I get y equals 9 can simplify into there. I can take a 3 out of each one. And this will be, let me see, 9/3. Oh, let me see, 9 times, oh, that's just a 3, yes. Plus or minus, 3 goes into there once. This will be the square root of 3 over 3. Again, how much do they want you to simplify and what will they accept? And again, showing this work on your blue sheet, you know, depends what they're looking for. If you don't get the exact answer, they may count it wrong. But we see you've done all the work correctly. And, you know, we give you lots of partial credit. Okay, let's raise it up a little bit. Now, for this next one, they want us to solve 35 in terms of completing the square. So let's do that. We have x squared plus, well, no, it becomes a minus when we bring that over to standard form. A negative 6x. I'm moving this over to this side, and then I'm going to move that positive 3 over as a negative 3 over there. Okay. So in completing the square, x minus 3, square this. I'll change colors. So I'm adding a 9 here. I have to add a 9 there. So when I factor this, I get this equals, do the subtraction, 6. So I've completed the square, factored it, got this binomial. Now I'll take the square root of this side, plus or minus the square root of that side. So I get x minus 3 equals plus or minus the square root of 6. Transpose that, and I get a positive 3. And now I can erase that, and that's my answers. So they gave you a rather easy one to work here. The thing is, put it in standard form. Let's see, I get my pen going here again. ax squared plus bx plus c equals 0. Okay, now they want us to use the quadratic formula to solve this one. Again, we have to put it in standard form. So this will be a negative 5y squared minus 6y. Transpose that 2 minus, on this side becomes a plus 2 equals 0. So let's get our next values here. Okay, so once we have put it in standard form, we can identify our A term, our B term, and our C term. Then there's the quadratic formula. So our B term is -6. So as it goes into the formula, the opposite of a -6 makes this a +6. Now we're going to square a -6 and get 36. Minus 4. A is a -5, and C is 2. And that's all over 2 times A, where A is a -5, gives us a -10. So take a moment to work this. I will work it, and we'll see what we get. So taking this a little further, when I worked with the discriminant, I get a 76. And 76 I could divide into 4 times 19. And the square root of 4 is 2. So I have this then on the top. And I'm going to factor out a 2 here. So this would be 2. 3 plus or minus the square root of 19 all over, and I'm running out of room here, a -10, which is something, and I'll get back to that in a minute. Okay, so I've rewritten this over here, up over here. So, and I've taken that -10 and divided it into a -2 times 5. So here I cancel this out, and this becomes a negative in front of that parenthesis. So this will become a -3 then, plus or minus the square root of 19 all over 5. And that seems reasonable. Wow, so that was a kind of a difficult quadratic formula that they gave us there. All right, let's go on to number 37 here. Let's raise it up a little bit. I could remember doing these here. The number of seats exceed the number of rows by 15. So let's just look at that for a moment. So this is the number of seats, or number of rows. So this will be the number of seats. And I recall doing many like this. And that total is 2, 4, 9, 4. So this becomes x squared plus 15x. Transpose that, negative 2494 equals 0. Now, this is actually factorable, but, spending the time to do it, depending how much time you have on your final exam, I have an easy way to factor it, so I'm going to just factor it using my special technique. If you factor that, these are the factors, equal each of them to 0. So our answer is find the number of seats that are in a row. So this is the number of rows, and if we add 15 to it, we get a 58. 58 times 43 gives us this number here. So this is the number of seats in a row. And it took quite a deal. That was a really challenging one here. All right, let's go on. We only have 40 questions, so we're getting close here. All right, consider the following function here. Let me raise this up a little bit there now. Make a list of x and y values and graph the function. Okay, so here, this is one of our basic functions. And again, this just takes time. Just to get our curve here a little bit. And let me set this up here too. Now, I believe on your papers they give you a graph to choose from. So we've done some points, and the key is whenever x is 0 here, anything to the 0 power is 1. So our graph is going to go right there. Let me get a... Now, if x is 1, 1/5 of the first power is 1/5. So that comes about like so. If x is a -1, remember it would be the reciprocal of that, so it would be 5. So 1, 2, 3, 4, 5. It's going to go like so. And then it goes up to 25 here. And it gets closer and closer to the x-axis, which is your horizontal asymptote. So that would be this one. Now remember, if this were y to the 2 raised to the x power, or if it was y to the 5th power, it would be the reflection of this, and to the 2nd power would just be out a little further away from the y-axis. So things that we had covered in our lecture. Let's go on. Almost finished now. Okay, now these relate to the last few lessons we had on probability. So let's read it over and come up with a strategy. So you're going to select a black card. Well, the probability of selecting a black card, we said, was half of the cards in your deck are black. So that would be 26 out of 52. And you're going to select a queen. Now the queens, there are 4 queens in the deck out of 52. But 2 of the queens are black. So we have to subtract that from the queens here. So 2 out of 52. So this is going to be a 2, so this is going to be 28 then out of 52. And then we take our calculators and put that in there and see what we get. 28 divided by 52, and I get 0.53846 and they want us to round to the nearest thousands. So we then go to the 10,000ths position. Since this is a 4, we just drop it all. If it were 5 or higher, we would drop it and add 1 to the 8. Okay, then we have one more to go. Let's look at that, read it over carefully, and see what we're going to need here. So in doing this, we have 3 categories. I made a Venn diagram. Our universe composed of 140, I guess I got carried away there, 140 students. And then 33 took history. So I'll just put this here lightly there. 39 here, science. 38 religion down here. But there's some intersection of these numbers. So these aren't, they're just a working system that I'm using. Now, the key to one of this is 3 took all 3. So we put a 3 right there. So right away now that takes away from these totals, but we're just using this to work here. Now, 17 took history, but not science. So we know that 17 here, in a sense, but not science of this. So that would reduce that number too. 3 took science, or I'm sorry, 12 took science and religion. So science and religion, we know this is going to be a 12 here. 13 took history and religion. History and religion, so we know this is a 13. And then we know 3 took all 3. So what they're asking us is a rather limited one. How many only took religion? So here it's unclear whether this 3 is applying to any of these. And I don't know, looking at what they're telling me. So I'm going to assume that this is what I have. And I have a total of 38 down here, as I said before. So if I add this up, I get, in these, I get a 28 here. So the ones that only took religion, if I subtract 28 from 38, I get 10. I believe that is what my answer is. And again, these are a little bit tricky and they take a little bit of time and analysis. Well, this is almost running another 37 minutes here, so let's close this one up and wish you good luck on your exam.